This is the research I found. This is done by two Vietnam researchers called CombiGCN and Effective GCN Model for Recommender System. So in their research, there are some brief introduction. Graph neural networks, GNNs, have become the state-of-the-art technology for recommendation system. And GCN, graph convolution network, is a special type of GNNs that uses convolution aggregations. And there is also a recent study developed light graph convolution, LGC. So you can see it as a light version of GCN. So we can say that GNNs or GCN are the most used recommendation models nowadays. However, there are some problem on traditional GCN-based models. So traditional GCN-based recommendation models only consider connections between user and items. So CombiGCN want to address this challenge by first create weighted connections between user based on their similarity, and they use J-card similarity. The second one is that they propagate embeddings through both graphs simultaneously and then combine the resulting embeddings using a simple weighted sum approach. So on combined GCN, the main innovation is how it combines two different graphs. So the first one is a user item interaction graph. This is like a more traditional approach used by GCN. Their innovative part is that they also use a user-user weighted connection graph. So user-user weighted connection graph, they are also a similar approach on others model. However, the innovative part of it is that they have their specific way they implement the weighting, the dual graph propagation architecture, and the simple embedding combination method. And then they normalize the user-user graph using J-card similarity. So this is like a general design of combined GCN, which has three different components. So the first one is embedding layer that use the unique identities of users and items to create embedding. And then the propagation layers, which propagate the representation of users and items in OGC architecture. So on the embedding and propagation layers is that user embeddings propagate through both graphs, and item embeddings only propagate through the user item graph. And then on the prediction layers, it predicts a score between user and items paired based on final embeddings obtained after propagation layers. So the final embeddings are used to predict user preference for items through inner product operations. And then this is the experiments they did. So for the datasets, they use three different well-known datasets, and each dataset is being pre-processed and divided into two sets, which are 80% for training and 20% for testing. And for the setting itself, to ensure that the experimental results are fair, they set the parameters to be the same across all models. And then these five are the old baseline models they use to compare with CombiGCN. So these are the results they got. CombiGCN outperformed several state-of-the-art models on three datasets across precision, recall, and NDCG metrics. And the improvements demonstrate that adding weighted user connections help capture better collaborative signals. So why it matters? The first one is that CombiGCN better captures the similarity between users in a mathematically sound way. And it also simplifies the embedding combination process compared to previous approach. And the last one is that CombiGCN demonstrates the quality of connections between nodes, not just their existence. It's important for recommendation system. Yeah, so this is all for the research, and these are the question and answers. So the first question is that what problem does combined GCN aim to solve? So it addresses how traditional GCN-based recommendation models only consider the existence of connections between user and items without accounting for the strength or similarity of these relationships. And the second one is that how does combined GCN construct the user-user weighted graph? So it uses J-card similarity to weight connections between users based on their shared item preference. So it creates a graph where each weights represent user similarity.